Hello, everyone. Good afternoon. Good afternoon. I'm Theresa Vaughan. Before we begin, a little truth in advertising. You might have noticed that Adam Molnar is missing today. He's the co-founder of Wearables, and he unfortunately has contracted COVID and is doing the socially responsible thing and staying away. So we won't have him here, but he assures me that if you contact him on LinkedIn, he'll be happy to answer any questions you have. So, and if you do have questions and they're not answered today, I want to say, please make sure that we receive them so that we can give them their just desserts after the panel. So now to the business at hand. Thanks to G3, ICT, and the organizers of this very interesting and important meeting, and an advance thank you to my august panelists. I am a neuroscientist, and I work at the National Center for Adaptive Neurotechnologies, which is at the Stratton VA in Albany, New York, and also at WashU and MUSC. And I am the chair of the advisory council of a project called NeuroAbilities. And NeuroAbilities is the latest project of G3 ICT. And NCAN has partnered, my laboratory has partnered with G3 ICT to investigate how the burgeoning field of neurotechnologies, including brain-computer interface, can learn from the many years put into generating accessible devices, and to convene stakeholders in a dialogue about how this very interesting and sometimes misunderstood technology, these technologies can be made available to people who actually need them. So that sets the stage for my three panelists. Before us, they are titans of accessibility. They, between them, create, test, and market software and hardware that address, among other things, accessible and wearable tech for people with disabilities at work and at play. So I'm going to let them introduce themselves and talk about why they agreed to be on this panel with me, because they're interested in neurotech and they're adjacent to neurotech, but not exactly involved directly in neurotech. And so they are going to school me and you and my colleagues about what lessons we need to learn in order to develop accessible technologies. So I'm going to just interview these three stakeholders here, just as I would if I was involved in getting them to participate in NeuroAbilities, which, by the way, at least one of them already has participated quite a bit, Cathy. First, Cathy Bodine, the Executive Director of the Assistive Technology Partners at the Center for Inclusive Design and Engineering, and an assistant professor at the University of Colorado, Denver. She has expertise in evaluating technologies intended to support independence and quality of life. Alex Dunn, next to Cathy, is the CEO of a startup called Enable Play. There he helps individuals and groups, including educators and businesses, turn almost anything into new input for their computers, game consoles, and more. Finally, but not last but not least, Darryl Adams is the Director of Accessibility at Intel. Among other things, he is the originator and directs the Accessible Computing Innovation Program, an effort to embed inclusive designs across Intel's entire PC portfolio. And that has, as you can imagine, the power to affect not just millions of people, but billions of people. So, a pretty powerful group. And I'm going to start by asking them, why did you agree to be on this panel? And who are you to tell me what to do? So, Cathy?
Okay, so I'm on this panel because I like Theresa. And she's a very good person, so I decided I would say yes. On the other side, I actually am a professor in bioengineering and also joint appointments in the School of Medicine. I'm the executive director of the Coleman Institute for Cognitive Disabilities as well. And I work at that intersection of the end user at the center, engineering and medicine, and then of course the ecosystem that surrounds these folks, whether it's school-based, it's vocationally based, it's play-based, whatever it is. And I have a real passion for thinking through what it is we're actually doing. And what is it that these folks actually want and need versus what do I think? Because what I think doesn't matter. What matters is that we're serving the needs of the people that are requesting some form of assistance in whatever way that goes. And so I'm here because I think that we have this tremendous passion and suddenly, particularly following COVID, this massive industry interest in our work. I think COVID, the silver lining of COVID for people with disabilities is now we all know what it's like to be isolated, and it doesn't feel very good. And so trying to help all of us come to some form of consensus around what is it that we're actually trying to do in this space.
Thank you. How about you?
Hey everyone, I'm Alex Dunn. I'm on the panel, I think, not so much for any type of background in neurotechnology or neuroscience, but more so because, from my point of view with enabled play and just even generally speaking, looking at new human-computer interaction paradigms and ones that are more ubiquitous and inclusive. We sort of take a hard look at how we as humans interact with our technology, and at its lowest level, while there's more accessibility, the usability is still not equal. So from our perspective, it's taking anything and making it a way to automate and leveling the playing field for everyone at a higher level rather than trying to catch certain pieces of technology up. And neurotechnology is an important aspect of that. When you're talking about that ubiquity, it's not just anything that's mobility driven. It's how do we get from thought of what we want to do, what action we want to take, what information we're looking for, to that action, to actually seeing it done. The closest we can get is actually just reading your brain. So it's a very interesting aspect to be looking at, but we come from the side of really looking at the artificial intelligence and how to apply that to the problem, which is a very core piece to make this type of neurotechnology work and to make this type of access work.
Thank you.
And so I am here today because I think, so ultimately I just really believe in the creation of a future of technology that is inclusive and accessible to everyone. And I think that goes, so we're in the time that we have today, the time that we're in is pivotal. And when we look back on this time in history, we're going to realize this, that we're now shifting from a paradigm, a 40-year-old paradigm, where it's been the PC and the laptop is a computing experience, and we're getting more and more deeply into the types of different interactions that Alex was just describing. So I think Alex and I come at this from very similar viewpoints, but different lenses in terms of coming from the startup landscape versus the tech global corporate landscape. How do we come together and actually create that vision and execute on it so that the future that we're talking about doesn't leave the disability community behind? It's very, so from a personal perspective, I have retinitis pigmentosa, so I'm losing my eyesight from the outside in, and I'm also deaf in my right ear. And so I've been at Intel for 25 years, and for the first half of that time, I was a technical program and project manager doing research and development projects. The second half of my career, I was dealing with how do I keep my job when I feel like I can't do it like I used to be able to because of my declining eyesight. So I started having to understand, basically dig into the landscape of assistive technology and accessible solutions, and for my own purposes. But not long after I started doing that, I realized that, well, I was hooked, basically. Like, recognized the power of technology and what it can do to bring people together and make people productive. And so I made it my mission to figure out how to make, position Intel in a place where we, as a global tech company, can make a difference as well. And so that's my perspective on this. But and certainly in terms of the topic today, this is where the future is going. Where there's a lot to be said. There's still a lot to be learned, and we'll see a lot of failures as well. But this is I'm very excited about where we're headed in terms of interacting with compute, with BCI and other sort of non-traditional means.
Thank you. Thanks. So I guess I want to tell a little story before I ask the next question to the panel, because Cathy whispered to me before we started, what exactly do you want us to talk about today? And even though we've met several times to discuss this is a huge area. And in fact, I had the same conversation with Excel when we started the project. I'm a BCI researcher. That means brain-computer interface. And what brain-computer interfaces do is record signals from the nervous system, interpret those signals, and deliver user intent. And that's a closed system. That means that BCI is a combination of, the system is a combination of two adaptive controllers. So it's the device end and it's the human end. And therein is the challenge, the real challenge for the science, because an underlying understanding of how the brain and the central nervous system responds, both motor and sensory, is essential to solving the problems of people who have those issues, motor issues and sensory issues, right? So this marriage of accessibility, of people with those kinds of, people who need accessible devices, and the questions that you're asking every day for all of the technology becomes essential and central to what I am doing as a scientist. And so I wanted to say that, but I also wanted to say that Excel is not a small thinker. And so he wasn't interested exactly in brain-computer interface. He was interested in leveraging the excitement around neurotechnologies. And neurotechnologies is a huge area of study. It includes so many things. And so cochlear implants are neurotechnologies, very successful neurotechnologies, and they're very useful. And and perhaps we could see the exoskeletons that Sandy demonstrated yesterday as a neurotechnology, because it depends on the central nervous system reacting with some plasticity. So in some ways, I just want to say, this is a very difficult topic to cover. But what I'm interested in here is the panel telling me exactly what I'm missing. And for those individuals who are involved in startups and developing products, like our missing panelist, for instance, I think the message needs to get out that people with accessibility needs need to be involved in the research. So I have some questions. So the big question is this, and I expect this to generate a conversation among the panelists. What are the recent advances in gaming and wearable tech in your industries, in hardware and software, that can be leveraged by developing neurotechnology, brain-computer interface, okay, for me, to help ensure accessibility? And how might these industries neurotech, gaming, and wearable technologies combine to be more than the sum of their parts. And I think I'm going to direct this question first to you, Darryl, because you said something in our prep session that really struck a nerve for me, and that was about keyboards. And so I wonder if you'd like to just talk about losing our keyboards.
Yeah, this is actually a big topic on its own. If we think about what I just mentioned, that we've had 40 plus years of computer interaction that has been defined or designed as a keyboard and a mouse with a screen. And when that design was first developed, it was not developed with people with disabilities in mind. You wouldn't develop a computer with a screen for someone who is blind. You wouldn't have a keyboard as a primary input for someone who is not physically able to use a keyboard. But we've gone through 40 years of basically working around these design limitations with some pretty fantastic results, with many of the people here in this conference as well responsible for that. But it still gets to me where that when we talk about human computer interaction or human technology interaction, there's an opportunity to change the relationship between people and technology, and to allow technology to facilitate more effective communication and connection between people. So I think as we move into more immersive computing paradigms, so like kind of all the buzzwords that we've been talking about at this conference and everywhere else, the metaverse, virtual reality, and augmented reality, and all of this being fueled with various flavors of machine learning, natural language processing, computer vision. Put all this together, we now have capabilities, computing capabilities, and sensor capabilities that really give us far more latitude, breadth to design experiences that can that can basically emphasize how people can interact with technology. So if you're not a keyboard user, let's not give you a keyboard. Let's have a more conversational computing approach that can accomplish the same end goals. I think, and what's nice about this, or at least the trajectory that we're on, when we think about like VR, like right now we're trying to solve that problem. So now you've got this immersive experience, and the keyboard seems kind of weird in that experience. So we're kind of pulling away from the traditional compute and coming up with a new experience. And I just can't help but think how powerful it could be to bring a new channel of information into that mix with a brain interface, and allowing the user to passively have produce information for the system to consume and to provide and to respond to it. So I think about things like, as you're interacting with an environment and the system can understand your state of your mental state in terms of, are you stressed, or are you focused, or are you fatigued? It can with that information, software developers can take that and go many different directions. You can help users in those situations, or maybe if you're in a gaming context, you could play on that. I could imagine if you're like you're playing a horror video game, and the system can understand what specifically stresses you in that environment, and it would make it more so, or something like that.
Oh my God.
Kind of dark, but I think it's kind of. But ultimately, like, so the opposite side of that could be some really good accessibility-related things where it detects stress and it changes the context, and it eases the stress. And this is not things that have to happen proactively, but things that just happen naturally based on this additional data stream. So these are things that I think there's so much down this path, and it's really exciting.
So what about that gaming experience, Alex? What do you think?
Yeah, I also wanted to, I guess, to sort of frame my answer, I wanted to go back to the first part of your question, which is the the advances in technology that have sort of brought us to this point, and really, like, are we at a point where these things are ready for gaming? And the reason why I think gaming is important is, in terms of computer interaction and compute in general, it's one of the most intensive things we can do from a processing point of view, which is why you need a graphics card to even be able to run it. But also from a human interaction point of view. You know, if I am, for example, going to just sit back and watch a movie on my laptop, the amount of control that I need to do is very minimal. I might need to go to the next episode or pause or leave or search. But when we're talking about gaming and the sort of spectrum of difficulty in gaming, you know, there's a really big jump to the most complex multi-inputs at the same time. So looking at are we there yet for the human-computer interaction model shift, and my answer to that, I think, is yes. For gaming, it's a great stress test for it. I think the reasons why we're getting there now is really advances in hardware and software. You know, we have massive compute in our pockets. A lot of times, even on our wrists, have pretty serious processors in them now. And significant amount of memory usage we're allowed to use. You know, most of our phones, for example, have like 8 core processors now. We can do incredible multi-threading. We can run machine learning models on the edge, which is, you know, what a lot of our work is focused on, which is sort of the hardware enabling the advances in software to be able to get to this point, because we can't create these augmented inputs and controls and automation without running machine learning. And we can't do that fast enough for something like gaming unless we're doing it on the edge, directly in the same place you're playing the game, which is already consuming all of that compute just to exist. And so, you know, from the perspective of the experiences that we're able to create, there's sort of backfilling existing games in 2D and 3D, but then looking into these new modalities in VR, where we have an opportunity to basically educate users on how to interact differently. One of the biggest challenges with shifts in human-computer interaction paradigms is adoption and learning curves. You know, even when we went from keyboard and mouse to touchscreens, there was still a big jump there, and it took years for people to regularly adopt it as quickly as they can other inputs. And I think we're seeing the same challenges in VR and AR, where we have these new augmented inputs and experiences that we have to create, and there's a learning curve, but we're working through it, and people are learning new ways to interact, which then can backfill other platforms and tools as well.
I have like 10 projects my team and I are working on right now that I'd love to talk about, because each of them fits into this space in some way. But I'm going to talk about some health tech, a project we're working on that's a one-off, but I think it really ties in with our subject matter, and that is we're working with, so if anyone knows someone with type 1 diabetes, you might know they can be hypo or hyperglycemic, meaning their blood sugars can go up or down. Turns out the end result of that is your brain doesn't tell you what's going on, but you become cognitively impaired during those moments. And there are 11,000 deaths that are recorded annually for people having car accidents. So one of the projects we're working with Dexcom, which is a continuous glucose monitoring company, and we are we're on the early stage of developing an app, very simple, that alerts people when their blood sugar's changing while they're driving. We're then planning to tie this in with an auto manufacturer, to be named, that will enable us to use autonomous driving features to help navigate folks off the road safely, or to the nearest ER, or to whatever needs to happen at that time. And this gets to that human-computer interaction in a very different, but I think compelling way, because it's taking a body measurement, if you will, and saying, oops, we have a problem which is influencing your neurology right now, and we need to do something about it. And so that's another very kind of interesting way that I think we can think about how these features can be utilized. Bunch of AI, bunch of machine learning, to your point, and yet at the same time, it could potentially save lives. And so we go to that extent. I also see that, for example, I talked a little bit about this yesterday. We're building a social assistive robot that is designed to help babies get all the practice they need. What we're really doing is neuronal development. So if someone is born with complex cerebral palsy, that is in essence a brain injury, right? And so the idea is if we can use machine learning, if we can use AI, if we can have a different type of affect recognition where you can understand how this child is performing and how their engagement, then we can work with them to hopefully over time develop a stronger brain so that they can 20 years down the road maybe go to college, or maybe they can live more independently. And so all of these pieces and parts, and yet everything I'm talking about, we're not touching the patient or the client or the user. And I think that's where this interests me a lot.
I see. So I guess what you've all said, I mean, has made me think a lot. One thing that you said, Darryl, was about sensors. But before I ask you more about that, because that's a hardware question, and sensors are essential for recording signals from the brain and very important for sending those kinds of, so I wonder about sensor technology. But I think it's interesting that that the three of you have mentioned, well, maybe Alex not so much, but anyway, the idea that information can come from the brain and that we can utilize that information, a data stream, to inform our technologies. The end of, so that's very interesting for me because everything we do changes the brain. And plasticity is a core, is key. Plasticity exists across the lifespan. And we're going to be changing brains, and that catching up with, maybe Alex, you addressed that the most. I mean, you know, we have to somehow be able to, in this technology, anticipate that we're going to be changing our brains. And I just wonder whether you feel like the technologies that you have worked with have, I mean, perhaps that's the diabetes example, where, you know, you're actually developing a feedback mechanism for the person that's adjacent. I mean, I know I use my phone to help me remember things, including my kids' phone numbers now. So I'm sure that this will be ubiquitous, but that's very interesting to me. So anyway, just as an additional signal, that's very interesting. So we give you an additional way to play the game, or get it. We could get additional information for technologies, and then we can have medical responses. So what about this idea of sensor and sensor technology? What's happening in the hardware world that might have an impact on this?
Well, I think in general, there's a number of just maybe obvious progressions where sensing capabilities are, like all technology, becoming more or less and less expensive to begin with. And so we're beginning to integrate sensors into devices at levels that had not been seen prior. And so whether you're talking about a phone with the sensors that it exists, that it possesses, or a laptop where it has the camera and then a growing number of sensors that are available in the lid to understand its context. So I think the driver is the cost. Like the cost and capabilities of these things are we're hitting more of a sweet spot where we can add more capability. So when you buy a device, it's not just available for a traditional command and response model. It's going to be more about the device understanding its context and understanding its user, and over a period of time as well. So there's a temporal component to that. And what you can get with that, if you think about how, if your device knows who you are and what your capabilities are. So let's say you are visually impaired, but you are, but you still rely on eyesight. The device can understand, or you can teach the device what you can and cannot see, and then it can produce that experience for you. And so theoretically, you should be able to have a device that never shows you something you cannot see. If it knows what you can see, why would it give you something different? And so it's that kind of personalized capability that I think that we want to be moving toward. The same thing for audio. If you are hard of hearing, but you still rely on hearing, why would your computer or your phone give you an audio signal that you can't hear? So it's these kinds of things that we can do with sensing technologies and AI. So everything is coming back to machine learning in different ways, which is going to be kind of supercharging all the things that we're talking about. But I think that this really the path here is that we're going from broad sort of utility technologies to really much more personalized technologies that can just be like super beneficial to people, especially for people with various disabilities that basically represent incompatibilities between the person and the technology today. We're trying to reduce those incompatibilities and make everything feel like it was designed for you.
I wanted to add a little bit around the sensors too. To echo Darryl's point, we have so many sensors on all of our different devices, and they seem to add more and more. Folks even now ship devices with sensors that aren't even enabled yet. I think Nest was one that did that with their thermostats. They had cameras in it that literally didn't even have power being sent to them yet, because they're like, we know we're going to want to use this sensor at some point to do something, but we also need to ship this device. The way that we sort of look at sensors in general is it's a way to detect intent, right? So whether that's coming from a BCI, whether that's coming from microphones and spoken request, if it's coming from a camera and being able to detect what we do with like face expressions and body gestures and those sort of micro movements that are personal to you, or our own screens and the touch sensors that we have built into them. In a place where we're underutilizing these sensors for control, the more ubiquitous it becomes, and I know I use that word a lot, but that's kind of where I think it needs to get to. The more ubiquitous the adoption of those sensors, and the more implicitly that they're used, we can get to that level of experience where, like you were saying, Darryl, like it just knows how you want to interact with it. And can just do what you want, because we can use anything to derive an intent. The biggest challenge beyond just understanding a sensor, like taking an accelerometer and getting XYZ deltas over a time period, is how do you actually turn that into an intent without making someone program every single thing to say, when I tilt my phone to the right, it should do this thing. And that's where context and really like LLMs, or large language models, I think, can advance that space a little bit more. To go from intent to really complex action, which is the area of research that we're focused on, taking any small sensor and knowing, hey, this person is trying to tilt their phone to the right, a very simple gesture, but they're doing that in this video game. We should probably be using that for a specific movement in the game, or we should be using that for a specific command or some type of action with their character, because we should know what they're trying to do implicitly ahead of time without them having to build everything from scratch.
So, Cathy, this wasn't on the list of questions. Is it? But I'm just wondering about evaluation. So your group has been so involved in evaluation, and I have to say I come from an industry that tends to overpromise a bit, because this is not rocket science, but it's something like rocket science. Not that I'm that kind of a scientist, but what I find is that there's not impatience anymore for brain-computer interface or neurotechnologies to solve the problems, but a kind of just tired, worn out, sort of like, all right already. you said we were going to do this, and you still haven't done it. So what is the problem? So, I mean, for me, that has something to do with, I mean, as a BCI researcher, that has something to do with markets. It has something to do with embedding the thing in the, you know, making the device like a toaster, and the support and the interest from groups to actually have this happen, and the science. But anyway, what do you say about disappointment and about evaluation?
I think if I were someone who worked every day to get through the day because of my disability, and I work as hard as people with disabilities work, I would be a little frustrated with people like us. Because we talk a lot, and you know, I have this friend of mine was the president of IEEE a long time ago, and he did this thing where he would throw his hands up and he would say, "Imagine if you will." And I finally got so frustrated with him one time. I said, "Will you just stop imagining? I have real people drooling on me on a daily basis, and they need us to quit imagining and actually do something." You know? So I think part of it is, you know, it's the 60 minutes thing where you see someone moving the robotic arm with the BCI, you know, and we're all thrilled, and then we figure out, oh, I can't have that. Or, oh, there's only so much of this happening. So I think we need to really think about our messaging. I think it would be very useful if we all came together and literally drew a picture of where we are and what's going on and where the holes are. We need to be feeding that to the federal funding agencies for sure, so they can start, because both NSF and NIH have put disability in their strategic plan for the first time ever, and assistive tech people. They both just did this in the last year. I'm just saying, let's think about this really hard. But we need to have a coherent message. And we need to be, I think, brutally honest with ourselves and with the individuals we hope to serve with where are we and what can we do. And I agree with these guys. It is ubiquitous. It is moving so fast, it's hard to keep up. And I'm right in the camp with you guys. But at the same time, I think how we message this needs to be open, honest, and clear. And we need to be inviting people with disabilities in much more than we do. Everything we do is user-centered, everything. And I don't think a lot of people are doing that. And then you see devices that don't work, you see sensors that don't work. You guys know the story. It's a choir out there. And I think we have to really get, you know, I think it's interesting that someone who is able-bodied can assume that someone with a disability needs X without asking if they even want it. And I think we do that a lot, and I think people are tired. So I think we just have to be better at our messaging. We're great at science, we're not so good at messaging, and I think we need to work on that.
Yeah.
Is that fair?
Yep, it sure is. Darryl, do you think that, well, I guess this follows something that Cathy said, to talk about embedding technology, you know, embedding the expectation that everybody is going to be able to use it in user-centered design, or retrofitting things. And how do you think the industry, your industry, is responding to that that issue of not having to retrofit, but rather to anticipate and involving users in user-centered design?
It's a really, that's a big question.
Okay, you got, like, I don't know, maybe a minute and a half. Come
Well,
on.
because I think, like, so the industry, like, this is where I want the industry to go, is to recognize tech, like, basically when we think about computer architecture or technology architecture, that architecture informs hardware design, and the hardware design is the complete constraint set that software developers have to work with. So when we think about, if you're writing software for a computer, you're writing software that's going to expect a keyboard entry, and it's going to expect the output to be displayed visually on a screen. That's how you write software for computers. If we think about how we create architecture that allows for a broader set of of hardware designs and a larger collection of sensors and all these different things, then we can actually start thinking about creating products that work for everybody, or at least are configurable to everybody's needs when you buy it, rather than needing to buy something additional or have a separate approach to getting something done. We have the capability to do this now, and we just need to be deliberate in our intent to do it. So when I think about we've all lived through 40 years of doing what we do. One thing I sometimes note to people is that when I started at Intel, it was late 90s, and I was able to get a laptop. It was kind of like the first corporate laptop pilot, and it was garbage. But it was a laptop, and so basically what I did on that was email and spreadsheets and presentations. And we fast forward 25 years, and I have a laptop, and I do email and presentations and spreadsheets. However, but we've made it far less annoying. So now it's light, it's fast, it's cool looking, but I'm doing the same thing. And we now have the technology with, it feels more cliche, and it feels like it's buzzwords, but that machine learning, all you can do with sensor inputs, and then we bring on this newer in terms of commercial application of brain interface. These are the things that these are new tools that we can bring to market at scale, and do different, make sure that everybody can participate. And I just want to add that as we move from this model that we're all so used to into different immersive models, we must bring everyone with us. If we make this transition and we forget people with disabilities in that mix, and then we have to retrofit VR, that'll be devastating. We have everything we need to not do that, and we have to, obviously we need the participation of the disability community, but the time is now to do that. And if we miss it, then we're going to be talking about this in 10 or 15 years, why VR doesn't work for people with disabilities.
I see.
The first thing I want to add is that right after this, we're going to get some games installed on your laptop so you can do
All right, okay.
something a little more than email and spreadsheets.
That was it.
So I would also add to that with gaming. So we're in the middle of a user study of a new product. It's a game, a virtual reality game, and we're testing it with people with a variety of disabilities right now. And it's truly interesting what rookie mistakes are made by developers. And so I would encourage us to really be thinking about education of software designers and getting into this educational arena now, so that we're teaching these new programmers, all of these folks, how to do this from the beginning. And that's something I think someone like M-Enabling could think about advocating for sure.
So I'm going to be a little combative there, just because historically when it comes to application development, in my background being in AI and application development, leaning on developers to solve accessibility just hasn't worked. And we saw the number was shared yesterday with only 2% of websites are accessible. It is way easier to make a website accessible than it is to make a VR game accessible. We're playing in two dimensions.
Yeah, I don't disagree
Yeah.
with you, but I think it's not even talked about in
Right.
those programs. That's where I'm at.
No,
We have to do
I
something.
totally agree we need education. I think, though, that it needs to come from product and down. Developers need to know about the tools that are there. But in the end, most of the way that software development works is someone is instructing what to build. And if their focus is not accessibility, not even just their focus, if that's not even on top of their mind, that's where, and I think we're really saying the same thing.
We are in agreement, yes,
yeah.
we are.
Yeah, it needs to come from leadership down. It needs to be a core part of culture to be adopted all the way through these teams into applications. And I think, honestly, with VR, we're at the right time to standardize around that and to educate everyone on it. But I think we need to do it now, because the second that VR becomes so much more widely adopted and it becomes another channel for every developer to build for, like web and mobile, if we're not prepared, then we're going to end up with 2% of VR games actually being accessible. And that's my sort of big concern with this space. And we need more accessibility solutions from much lower levels as well, in terms of being able to automate a lot of these things without depending on not the developer as in just the engineer, but the developer group of the application to implement it. We have abilities now, and we have the technology. We have the technology to solve these sort of ahead of time and in a more universal way. And I think that there needs to be a shift in focus there.
I agree. I also think we need to have the shift at the undergraduate level.
Oh, yeah.
Academic. That's where I'm going with the
definitely.
training. Because these kids are graduating and they don't know anything about disability.
Teach access.
Yes. Oh my
Yeah, Teach
gosh.
Access is a good first start, but I think we need to do lots more. Needs to be embedded.
Just need Teach Access everywhere.
Yes, we do.
So I think you might have some questions. Yes?
So this is Rob Fentress at Virginia Tech. So I guess like a lot of people who are aware of it, I'm like stunned by things like GPT-3, and particularly some examples that I've seen. One particular one where I saw an interview with Sam Harris, where basically, you know, it would ask questions and it was like an interview, and it would respond exactly with the philosophy of Sam Harris in, you know, in an incredible way. And thinking about this panopticon that we live in, or panauticon more relevantly, we have all this data of my interactions with all of the people around me, okay? And we will all have more and more trouble finding the right word. Some of us will have aphasia, and it will isolate us and make us not able to be independent. And it's almost inevitable for a great many people, most people, I would think. And so with these technologies, is anybody exploring taking that data and making it so that maybe there's a heads-up display? And when you start losing your ability to generate words, somebody says something, and it says, okay, this is what I think you would have said in response to this. Is that what you want to say? And then you could say it.
So this is something about, I mean, you're asking the question that Darryl, or a question around the issue that Darryl raised about personal, computers and hardware and software responding personally, and knowing you, knowing who you are. Is that?
Well, yeah. I mean, being able to respond or suggest responses as you would have responded in response to what somebody says to you.
Yep.
I mean, we're there now, right?
Absolutely. I guess I'll take it first. Sounds like Darryl also has some stuff to add. So for just some background, you'd mentioned GPT-3. For those of you who are not in the machine learning world, GPT-3 is an example of one of those LLMs, large language models, that essentially, given a short piece of context, is able to predict and generate more output. It does natural language generation at its core, but it does it in an amazing way. There's other similar implementations like T5, which came out of Google Research, and now T5X. When it comes to the way those are being implemented and creating new ways of actually using that in not just assistive tech, but in prediction, is a huge industry focus in machine learning. It's also exactly what we do, not your specific use case of predicting it and then showing you and giving you the suggestion, but we take basically explain what you want your computer to do, and we use a custom T5 model, large language model, running offline to actually generate the output and tell the computer what it should be doing at its lowest level. So there's a lot of research. That's where our heaviest research is. But that's really where the machine learning space is now. It's transformer models, and it's applying them to very specific problems like this.
Okay. I just want to, there's a question there's another question behind you, but before that, I think Cathy has a response as well.
Okay.
Yeah.
Oh gosh. So I love this, where we are with the tech. One of the things that we've been doing, though, is really, we're in the early stage of thinking through the ethics piece. So pre-pandemic, I was on a committee at the American Academy of Medicine or whatever, and we did an ethics in AI and machine learning workshop because, Congress is not going to legislate or regulate at the speed of our tech development. And so one of the things that we really have to think about is the ethics behind all of these things. We can do all kinds of crazy things, and we all want to. But we have to really also bring in the ethics side of this with it. Maybe that isn't the word you would want to say, but that's the only word that shows up, and your aphasia causes you to repeat it. So there's so much going on there, and so that space of the ethics is something that we really need to bring to play right now in conjunction with this wonderful development that's happening.
And I think that goes double for brain-computer interface.
It does.
I think Mohammed had a question, and then there was a question, there was a hand raised in the back, and then there's one over there. Okay.
Thank you. Hi, everyone. My name is Mohammed Lutfi. I'm G3 ICT Director for Capacity Building and Advocacy. Also a member of the NeuroAbility Technology Initiative Advisory Council. Actually, I have a question, and I hope it won't sound complicated. And this
Come
is
on,
something
Mohammed,
that
of course it will.
since I've been invited to join the advisory council, my focus in my discussions and questions is always about this concept of user-centered.
Yes.
And my question is, how do you find your candidates to run your experiments? And to what extent you think, and this is my question, this question to Cathy, to what extent you think that BCI is extending beyond the medical model of disability and enhancing the social inclusion of persons with disabilities?
Mm-hmm.
I know the answer, but I would like to hear your perspective. And
All right,
also,
we'll call on you next.
yeah, and also, how do we make sure that this technology we are talking about is not limited to those who are nerd or those who can afford it?
Yes.
We want to
Right.
make sure that this is deployed to people who can afford it.
Yeah.
I mean, who are poor or who are, unaware of what's happening in this world. So, thank you.
Okay, well, I'm going to let Cathy take the complicated part of that question in a minute. I just want to say that one of the goals, I think, of NeuroAbilities has to be that kind of inclusive space for people like me who might cherry pick a population, a group of people, in order to keep my cohort simple. So, I think Roger Smith, whom maybe some of you know, Roger Smith asked this question some time ago in the context of neuroethics, and he said, one of the ways in which we can continue to not understand how people with disabilities may be the same or different is to keep them out of our experiments, because we have to keep our cohort. We want to ask a simple question and we want to get a simple answer, but that limits our understanding of exactly how the brain works, especially if someone doesn't think the same or pay attention the same, follow instructions the same. So I think it's a really, really good question. So, Cathy.
Okay, so I think I heard about 5 questions in there, so I'm going to try to remember everything I can. So first of all, the subjects, that is a huge issue. And I am blessed that I work with a group of folks who, as part of their practice, they work on reducing disparities in healthcare, including people with disabilities and tech and all that. So we recruit widely broadly and deeply. And, you know, because I'm old, I have lots of friends all over the state of Colorado and in other states, and I can pick up the phone or I can send an email, and I'm pretty fortunate in the regard of being able to do what I need to do. But we match demographics. So, for example, if there's 8% Hispanic, if there's, you know, 40% white, if there's 23% black or whatever, we match our demographics in every single study we do, because if you don't do that, you have made the biggest mistake of your life. We do work in multiple languages. We bring in sign language, whatever we need to communicate effectively and clearly. So we're very passionate about ensuring that everyone is involved in the research. Now, we're doing a study right now which has nothing to do with neural, but it's looking at dynamic seating systems in power wheelchairs or in wheelchairs in general. So people that are very spastic, if you have some give in your seat or somewhere in your legs or whatever, that can keep you from breaking bones, and it can make you much more comfortable. And so we're doing a health disparities study right now and figuring out, going through Medicaid to see how many people of color actually receive the dynamic seating system versus people who are white. And we're going to be using that as an example. And I think we have to stop.
Yeah, I think we have to stop very shortly. There were 2 more questions left. Can we take those questions? Or? Yeah, okay.
Hi. My name is Nahat. I'm from Alana AI. We're a deep tech AI company based out of Edinburgh and London. I'm sure I think you may have come across our research team. Professor Theresa and Professor Oliver Lemon lead it.
Very quick statement I wanted to say is the biggest return on investment you'll find.
No, she can't hear you.
Okay. Can you
work
hear me?
alongside.
Okay, excellent. So we work on
Give me a
building basically
explain.
companions using both natural language processing and vision, and we're combining all that technology to deliver a new experience, grounded AI, which is safe and bias-free, which is in opposition to, I guess, what we've seen in large language models and GPT-3. So I guess my question to can you hear me now? Okay, so my question is really to Cathy and Darryl. So, you know, what are the plans for the future, especially with Intel, to actually implement AI, which is grounded, which is safe to use across the board? And I think there's a massive disparity in terms of user experience and being able to actually use AI, because I think it's an overly used word, and it seems that. To me that it seems to me that we've got a lot of people working on amazing things that aren't necessarily being deployed in the research space, and I think there's a massive disconnect between the big players, Google, Apple, etc., in terms of implementation of the technology, because there's disparities in the way that you develop the technology and also the tools that those big players allow you to deploy for accessible users effectively. Apple have a completely different book. Google have a completely different book. And if you try to deploy in those Android and iOS devices, it is difficult.
Well,
and we're seeing that. Sorry. So the question.
Yeah. The question.
Yeah. So the question is how. So the question is, how do we make it easier to work across all the major big players? Because that is going to make the difference.
Yeah, I think I'm going to let Darryl field this one, at least to begin with, and then we'll hear from Cathy. Just because you do represent a big player.
Yeah.
Right. Well, so I don't know. There's a number of things there, but to begin with, I totally would agree with the initial premise that we need to be doing things in as ethical manner as possible. So at Intel, we have a responsible AI council that all of our AI projects have to run through from the beginning. This is not the solution, but it's definitely steps in the right direction to ensure that we're making that the projects we're choosing and the way that we're implementing and the training data sets that we're developing we're asking the right questions and trying our best to be bias-free or reduce bias and all of the other elements that's necessary to be responsible in this space. As far as, so the challenge though, what you're talking about with the cross industry and how do you make these open, we definitely come from a perspective that we want an open ecosystem, and that's where we're grounded, and most of the work that we do is open source in that space as well. The challenge becomes that there's business models around these things that are proprietary for depending on the company. They have different models, different reasons, but that, I don't know if you tie your revenue to these models, I'm not sure how you can get around that. Our approach is to not do that and to make sure that we're creating hardware that can accelerate AI workloads to the best that we, to meet that, like whether it's at the edge, in the data center, wherever that takes place, but optimize it for the specific type of workload, and that's what we're interested in. So I don't know that it doesn't answer your question, but I'm not sure that there is an answer.
Okay, Cathy, do you want to?
And yeah, just quickly, one of the things I think maybe going down to smaller companies. I met just 2 days ago, in fact, with this amazing, brilliant computer scientist who's coming up with a different approach on bias-free machine learning, for example. And I think that has to form the core of what everyone is developing. And I think for smaller companies that maybe don't have as much access to the talent that larger companies do, we need to figure out a way to get that out, because that's going to make a huge difference. And if we can use open source, we should do it, but we have to look at this very carefully.
Great.
I'm going to.
David Fazio here with Helix Opportunity. I just wanted to quickly say that the Cognitive Accessibility Task Force with the W3C, the Accessible Platform Architectures Working Group as well, we're working on standards and specifications that used to be called personalization, which I heard a lot of talk about customizing, predicting user needs. So this is the holy grail of cognitive accessibility, right? We want to be able to have things customized for our needs and for us to just show up and have the platform know what we need and transform itself in that way. So it's now called WAI Adapt, WAI for Web Accessibility Initiative, capital ADAPT. I can't remember what the acronym is for that right now. So it used to be the Personalization Task Force. So what I'm going to ask all of you to do is to please look up our public, I'm on all of them. I'm going to ask you to look up our public mailing list on the W3C's website, and please start to share your work so that we can comment, we can bring it into the fray of what we're doing and stuff like that. And also, I heard a lot of things that really kind of sort of ring home to what we're doing in our innovation sprint on cognitive accessibility testing. So the same themes that we came up with is it's hard to communicate the compelling business case to focus on cognitive accessibility. It's not just an edge user case. We all get cognitively fatigued. You mentioned car accidents. So accidents are the #1 cause of deaths in the world. And it's because of cognitive fatigue. Cognitive fatigue causes stress, which creates cortisol in the brain, which prevents you from short-term memory making, which has a lot of different issues, right? So coming up with these compelling business cases and getting them from the top down is super, super important. And I just wanted to reiterate that.
Yeah, and I guess that this also would involve regulation as well. So and the understanding that maybe some of these things have to be supported by government. And I guess Cathy's comment about the NIH and NSF including accessibility in their mission statements is quite significant when it comes to that. So,
And there's strategic plans.
And their strategic plans. Oh, sorry. Okay. So, are there other questions?
We already have.
All right. Well, thank you, all of you. Thank you to the panelists, to G3. Tough panel, a tough bunch of questions, but thank you very much for attending.